Welcome to another episode of Earth911's Sustainability in Your Ear, the podcast conversation about accelerating the transition to a sustainable carbon-neutral society. I'm your host, Mitch Ratcliffe. Thank you for joining the conversation. The future lies in our farmlands. As the fossil fuels industry fades, crops like camelina, a flowering seed oil plant that thrives in the Mediterranean region, may serve as a source of biofuels, feedstock for bioplastics, and nutritional oils. We welcome back Dr. Oliver Peoples. He is the president and CEO of Yield10 Bioscience, and we're going to talk about the company's progress in engineering camelina to, as the name suggests, yield more oil for a variety of uses. Since he last spoke with us 2 years ago, Yield10 has announced agreements with Mitsubishi Corporation and American Airlines to develop biofuels and progress on developing camelina strains that are more efficient and herbicide-resistant. During the fall of 2022, farmers in the United States and Canada planted Yield10 engineered camelina as a winter crop for the first time. In addition to oils that can be used in fuels and bioplastics, camelina might be used as fish feed in order to increase the production of omega-3 fatty oils in the fish. And tests of the plant-grown version of omega-3 oils for human consumption are underway. Because it's a Mediterranean plant, camelina is suited to warmer climates, including the Southwest and the increasingly hot parts of the Great Plains. With farmland and soils in decline and the frequency of drought on the rise, humans must find ways to produce more with less. Genetic engineering, however, remains a controversial subject, and the introduction of herbicide-resistant strains of camelina could encourage the use of more soil-harming weed control chemicals. Oliver is an evangelist for regenerative agricultural practices, which typically discourage the use of chemical inputs like herbicides. So we'll unpack the implications of genetic engineering of crops and how they are grown with him today. You can learn more about Yield10 Bioscience at yield10bio.com. Yield10 Bio is all one word, no space, no dash, yield10bio.com. Welcome back, Ollie. How you doing today?
Oh, pretty good, pretty busy, but it's an interesting time for us, that's for sure.
Well, it certainly sounds like it. You've made a lot of progress over the past couple of years. When we last talked, your emphasis was on bioplastic, but you have a much more diverse portfolio in terms of fuels and other things like nutritional oils today. How has Yield10's business changed since we spoke in 2021?
So basically, what we've always, I would say, we've obviously got a number of opportunities in front of us. I would say all very much in the sort of sustainability space. Mm-hmm. But of course, what's happening is we're responding also to market dynamics. And because we were developing the oilseed camelina as a platform crop, mm-hmm. Ultimately in the long term targeting bioplastics, we also knew it was going to be very useful for making specialty oils for nutritional applications. But right today, we're literally overwhelmed with interest in feedstock oils for biofuels.
Really?
It's just exploded. It's globally exploded on us, and it's just creating tremendous interest in what Yield10's doing.
Well, now, you did introduce or announce a partnership with both Mitsubishi Corporation and American Airlines to develop the biofuels business. Tell us about the shape of those relationships.
Yeah, so obviously Yield10 is really, I would say, on the technology and the seed development side. And so, if you look at biofuels, there's multiple players along that value chain from the harvested grain from the farmer. You need to basically take it through a crushing operation to extract the oil. Mm-hmm. Then it has to go to a refinery to produce biofuel, whether that's renewable diesel or whether it's sustainable-aviation-fuel. And then, of course, that has to get into those markets. And so, with Mitsubishi, it's pretty clear their interest is the oil from the crusher basically going into the refinery. And they're working with a partner in Japan to convert a refinery there over to SAF production. And a very exciting opportunity for us, and obviously a large global player. And so we're delighted to have these discussions ongoing with them. And then American Airlines, that's pretty much a bellwether U.S. company. And of course, their interest is seeing sources of low carbon intensity feedstock oils available for SAF production, because ultimately they're going to be a large SAF customer.
So how does Yield10 earn its revenue primarily? Is it selling seeds? Is it doing the plant engineering for a particular purpose?
Really, what we're doing is doing plant engineering to enable growers to plant camelina seamlessly into their current crop rotations. Mm-hmm. Initially in the Pacific Northwest as a single season monocropping basically either a spring variety or a winter variety.
Mm-hmm.
That gives growers tremendous optionality in terms of adding a new crop into the rotations. They're very excited about that. And some of the biological attributes of camelina being faster growing than canola, for example, requiring less inputs. In other words, it's just cheaper to plant, is making this a very attractive proposition for growers in that region. But of course, growers are primarily interested in, well, who's going to be the customer for the grain?
Right.
So obviously, the way these agreements work is Yield10 really execute a growing contract with a farmer. We have the right to buy all the grain at the end of the harvest. Of course, that's why we have these partnerships with the downstream players to buy the grain and or oil from the grain from us. That allows the whole thing to work.
So you're a supplier, but you customize the supply to the need.
Exactly. And I think in biofuels, what you're really going to sort of step back and think about is, what's this demand, right?
Mm-hmm.
I think globally, we're looking at somewhere around, it's sort of 35 billion gallons, which is the 35 billion gallons of additional vegetable oil. And obviously, you're going to see, and we're already seeing it, we're seeing pressure. For example, the EU just put in a new SAF requirement.
Mm-hmm.
Biofuel 6% by 2030, and I think 70% by 2050. And then you start calculating how many gallons of feedstock oil is that, and the numbers get really big in a hurry. And then you just look at what's going on in the US. Same thing, whether it's for California for RD or SAF production, we're looking at 6 to 10 billion gallons of additional need here. And that's a major challenge.
So why is camelina particularly suited to genetic engineering? Why did you pick that particular plant?
Yeah, we started working on it. We selected it way back in, I would say, around 2010. And really we looked at it and said, this is a non-food crop. It's not native to North America. So if we're going to engineer this crop to produce interesting products like bioplastics or other specialty oils, or it's a very good, a very attractive platform. And it also happens to be very easy to genetically engineer. It's just the biology is just well suited to it. Fast. So, we can literally go from an idea in the lab to field trials within about, 12 to 18 months. It's very, very quick. And that allows us to test a lot of things. And we've used camelina really as a tool to develop genetic improvements that could be used not only in camelina, but potentially in other crops. And so, that's why we started working on it. But the reason it was brought to the US in the first place was around the mid-2000s for biodiesel production. And the same issues, which is it's a non-food crop, not native to North America. It doesn't require as much water or as much of a very long growing season. And so it always had this potential to become a crop in its own right. And what's happened now is you start looking to, add 6 billion gallons of feedstock oil. And what was missing from the equation is now there. It's basically the demand for the product.
So how much acreage in the United States or in North America could grow camelina? And how does it fit into the annual farming cycle, to your point earlier about
so right now, I would say probably Canada's probably 5 to 7 million acres US. You can literally pick any number you like. I mean, there are some USDA reports of 35 million acres of potential. But if you think about a crop like this and you think about the demand and you sort of say, this is now a crop worth investing in. And that was always a challenge. Why would you do this? Well, we're doing this because camelina produces a very useful oil for biofuels that has a low carbon intensity. And particularly in the US, if you double crop it so that you're using it as a winter cover crop in addition to a cash crop with a harvest value, that's a huge differentiator for cover cropping. So
how does that change the profile of the revenue that a farmer can earn from their land?
So right now, we've been talking to growers in Kansas and other areas, and just as part of our development, and what we're learning is farmers are adopting cover crops anyway, just because of the sustainability benefits for the soil. One of the big things I think farmers are particularly interested in, their assets, the soil, and the organic carbon content of that soil is a key part of that value. And so they're adopting cover crops to retain the quality of the soil, to reduce nutrient runoff, and because there's other benefits, over time in their farming practices. However, today, most of those cover crops at the end of, when you go to plant your next season's spring crop, you either kill them or you plow them under.
Right.
And of course, that's a loss. So with camelina, if you could get those same benefits, but now you harvest it and it's extra cash. And so, basically what it is an additional revenue opportunity that comes along at a time when, the equipment for harvesting would not normally be being used.
Right.
And the equipment for planting would not. So it's almost like you get to reuse assets that you've already which have already been capitalized for your regular spring, summer crops. You get a reuse of it. You get an extra crop off the land, and you get the cover cropping benefits. And so it's a very attractive thing for growers.
And because it's a winter crop, you don't necessarily have to water this very much either. So this sounds like it's very water efficient.
It's very water efficient, and really, and for example, for parts of Canada where we're doing this, we have about 1,000 acres up there. This planted last fall, which is probably still somewhat under snow in some areas, but some of it's come up and it's looking pretty good as far as we can tell. But of course, you're right. It's taking advantage of the winter moisture. It's established in the fall, and then it sort of goes dormant over the winter, usually under snow or not under snow, as the case may be. It's very hardy. And of course, it's very well, it's sort of ahead of the curve in terms of growing very quickly in the spring. And so it can come up and it can mature much sooner than the spring crops. It's very like winter wheat in that regard.
Right.
So that's probably a good analogy. But then I think when you go beyond that, you say, well, what about in the corn soy belt and perhaps starting in the southern sector of the corn soy belt? What if you could basically harvest corn, then plant winter camelina as a cover crop, and harvest it in April, May, and then you could plant your spring soybean. So in that scenario, what you're getting is an extra crop probably every 3 years, just because you've fitted it into the rotation. And so, when you sort of look at cover cropping, the way to think about it on a macro level is, we have about 180 million acres of soy plus corn production in the US. I believe that's probably about right. So think about it. That's during the winter, for the most part, that's all lying fallow. And during that fallow period, all the nutrients used for corn or soybean production are washing out of the soil into the water. And that's, of course, a problem in the Great Lakes and down through the Mississippi into the Gulf because of nitrogen phosphate pollution, right? So what if you put a winter crop on it? It reduces that, number one. But number two, say you only did half of that acreage in cover cropping. That's 90 million acres of potential.
So how much biofuel might yield from a given acre? So, I mean, if there are 180 million...
Well, let's say you get, let's say you get 50, 60 gallons an acre. So you do 50, 60 gallons and you start thinking 50 million acres, and it gets kind of interesting.
Yeah, no kidding. Now, you've involved a rapid trait gene discovery and testing process. It's called GRAIN, for Gene Ranking Artificial Intelligence Network. How does it work? And can it be applied to other plants?
Yes, and so we developed this because one of the things that's happened is, given where we are today with genetic engineering technology for crops compared to where we were in the early 90s, it's light years different, right? So we have all the genome sequences and we have enormous amounts of data publicly available from, work that's been done by companies, academics, whatever. So we have all this data available. The challenge with data is how do you translate data into useful information and actionable targets, right? And so, you start looking at, well, if I have to change 3 genes simultaneously to get an outcome, which 3 genes do I target? Because if you do that, if you're just test every combination of 3 genes, you'd be looking at millions of experiments. So no, it's just not practical. So what that tool does is it really takes a bottoms-up approach to building a plant and then identifying how can I make it more efficient. Let's say, because a plant is basically it's water, it's nitrogen, CO2, and photons from the sun. That's what makes all of this, right? And so you can literally build up it's almost like a chemical engineering approach to building up what the plant composition is. And once you have the model, you can ask the question, well, if I wanted to make more of this or more of that, what would have to change? And we've done that in such a way that once we understand the effects the changes we're trying to make, we have some complicated math algorithms, which I have no idea how they work. But basically what they do is they then can be used to mine public information. that's available from the genomics work that's been invested in so heavily. And out of that comes you get a list of gene targets to accomplish this outcome. And you can prioritize them. And so, we have a classic case study we did. We simply said, well, we'd like to find some new genes in camelina that could increase seed yield and seed oil content. Mm-hmm. And so they ran the grain program. They developed a priority list of 4 targets. All 4 targets impact seed oil yield. All 4.
What kind of traits do you look to add to camelina? For instance, I read about a number of them, and the C3003 algal gene that you're using. How does it change? The plant is essentially serving as your factory. What does the factory make when you add it?
And essentially, that just makes it more efficient. It makes it a little bit more efficient. It debottlenecks a certain thing. C3004 is similar. C3004 is camelina gene. And what we found is if you increase its activity, you can see yield improvements up to 30% or so. That's a lot.
Absolutely. I mean, anybody who was looking at building a factory and thinking we could add 40%.
Yeah, and we've got others that, for example, C3007, and we found if you use CRISPR to edit all 3 copies, we see a 10% increase in seed yield.
This is a fascinating conversation. I want to take a quick commercial break. We'll be right back. And we are back to continue talking with Dr. Oliver Peoples. He is the president and CEO of Yield10 Bioscience. Ollie, can you summarize the range of changes to camelina that you believe are of value over, say, the next decade? Where can you expect to see this plant start to play a role?
So I would say, right now, I think the big focus we have, and it's really because of the fact that we can really begin to commercialize this now, is it's actually slightly off our grain targeted for yield improvement and off seed oil content improvement. We're really focused on herbicide technology. When we talk to growers, what we learned is they really, pretty much all the crops in North America have weed control built into them these days. And that allows the farmer to take advantage of, more cost-effective, but also more sustainable farming practices like no-till agriculture, where there's been tremendous benefits to soil health and carbon. And so they really are looking to us to develop that because they see that as enabling in terms of how they go from 100 acres on their farm to 2,000 or 3,000. It's really allows them to scale this crop very quickly.
Now, you talk about regenerative agricultural practices, but a lot of people who believe that that's the right way forward also are concerned about genetic engineering and particularly the use of herbicides. How does herbicide resistance engineering fit into the regenerative spectrum, and how do you explain that to folks who are concerned about it?
Yeah, so I think I think what ultimately has to happen here is the system has to work as a system. So when you look at what's actually happened with herbicide use in the US, we had a big shift from plowing all the fields to basically no-till agriculture. That had a massive net positive impact on basically soil organic content, which is obviously a big key to the whole regenerative ag process, right? So in fact, maybe some people disagree with it, but in reality, the benefits it's provided in terms of the health of the soil, the benefits of soil organic content are very, very high. And in fact, some areas of the country, particularly in the drier areas in the West, we would have had almost dust bowls if we didn't have this type of no-tilling capability. And so, there's no single answer to this very complex problem. But I think when you look at what we have to do as a society, we have to produce food in a more sustainable way, which means we really want to adopt cover cropping practices because of those environmental benefits, and that will make food production more sustainable. But we all want to eat, and we like to go on vacation, so we like to get on a jet plane. I'm not prepared to get on one with a battery for a long time. And so, there's a lot of demands that have to be met. It's not just that, the only answer is X or the only answer is Y. It's we need all the tools we can muster here because the problem is very, very large.
So what kind of herbicides does Yield10 use? And for instance, does it encourage the use of Roundup, which a lot of people are very...
Actually, you don't use Roundup. And, I know scientifically Roundup is a safe chemistry, but of course, there's a very big pushback on Roundup. It was the sort of lead, if you like, GMO trait that got everybody kind of up in arms. Very widely used, and you can still go to Home Depot or Lowe's and you can buy
it up today. Yeah,
because basically there's the tort laws in the US, and there's the science, and sometimes they're not quite in sync. That's just the way it works. So it's a safe chemical, and like all chemicals, it has to be used safely. But we don't actually use Roundup. We use something else. What we did, and we haven't disclosed this, what we did is we sort of looked at the herbicides that are being used in North America, and we asked the question, well, based on the new regulations for USDA APHIS for approval of these things, which ones would have the fastest path to approval, number one, but number two, which ones would basically be the best for the grower, where there isn't really a strong pressure from weeds that have become resistant to the herbicide. And Roundup, there are weeds that have become resistant to it.
Right.
It's perfectly normal. This is basically how things work.
It's evolution.
It's basically evolution, and you can't avoid it. Some people may not like it, but the reality is this is just how things work and how these continue to evolve. So we selected something that we know has got a tremendous track record of safety and use across 20 odd years. It's something that we believe has a fast path to approval. And it's something that the farmers, when we talk to them, they're pretty excited about it because it will help them in their rotations to manage weed pressure from growing, things like pulses and lentils and peas, which don't have herbicide technology. But what that does is when you grow those crops, very important food crops, what happens is you create all this weed pressure in the fields. And so what they see with the camelina is with the herbicide technology we're developing, they can actually better manage weed pressure on these other crops by using camelina as a part of the rotation. And they see that it's tremendously advantaged for where they're growing. It's just quite surprising to me.
Well, evolution is an amazing and challenging thing. Now, how does Yield10 and its research partners avoid accidentally introducing novel traits that might alter a plant's ecosystem in unpredictable or unfriendly ways?
Yeah, so it's interesting. This is where I think camelina. We chose this wisely because if you were doing this in plants that are native to North America, where they have relatives that are they can cross with in terms of cross-pollination, that would be one scenario. Well, actually, there aren't too many weedy relatives of camelina. There are just no known relatives of camelina that could be cross-pollinated and be viable.
Okay.
This has been extensively tested. And so that's one of the reasons. It's sort of got this containment built in because it's not native here. Soybean's the same. Soybean was brought here from China. It's not a US crop. It was brought to this country. And obviously, there are no relatives of soybean in North America that I'm aware of. And so that problem is not really an issue as such. Now, there are other crops that people are looking at where that is an issue. And certainly we pay attention to these things because, again, our number one thing we focus on is it's got to be responsible and safe. It's got to add value to the grower. Otherwise, pretty simply, they won't plant it.
Yeah.
And three, the products that we're making with these things should ultimately have benefit to society. And I think we're checking all the boxes.
Now, we were talking a moment ago about the trade-offs around restorative or regenerative practices. How do you counsel farmers to think about the balance between productive crops and restorative agriculture?
So it's interesting. What we're finding, and this is, again, what you're finding is farmers are adopting this anyway, and many states are beginning to put incentives in place to encourage this. And what we're finding is when we talk about, so they're doing it and they're losing money doing it. But that also tells you they're looking at the big picture and they're looking over the long term. And they're very smart business people. Otherwise, they wouldn't survive long in farming. And so, what we find is that when you talk about a winter cover crop with the cover cropping benefits and of value that they can generate cash from, it's a very easy sell. I mean, it is. They look at this and say, this is just extra revenue.
Do they have to give up anything or make any additional investments? Or
well, not really, because you can plant camelina and harvest camelina with the same same equipment you use for other things. So,
Okay.
that's and of course, on the contracting side, we make it easy for them. We're making this attractive to them. And that's the key, is to make it an attractive partnership with the growers for this type of crop.
And how much tilling is necessary after a camelina crop has been in the ground before you can put the next crop in?
Well, again, I mean, with no-till agriculture, you just follow the no-till practices. You don't have to till it. So, but that's the beauty. And this is the key. And and I don't want to. I'm not trying to demean anybody, but when talking to investors, you mean you want to make it idiot-proof? I said, yeah, that's actually the key concept. This has to be idiot-proof. And if it's idiot-proof and people generate revenue with it, and it benefits the soil and it gives them additional revenue, you're kind of and we're essentially producing products that are beneficial to society, whether it's biofuels or renewable sources of fish oil, or ultimately fully degradable plastics.
Mm-hmm.
That's checking a lot of very positive boxes across the whole environmental group as well.
Now, you mentioned some incentives are being put in place by states. Was there anything in the Inflation Reduction Act around sustainable airline fuels that is accelerating your business?
Yeah, I would say what's happening is I would say it's not accelerating our business, because there's a certain timelines required in agriculture. What it has done is, of course, it's increased the amount of investment going into SAF production, SAF production. Number one, renewable diesel production, and that's where those billions of gallons of additional requirements are coming from. And that have turned, of course, this is everybody from Exxon, Chevron, Phillips 66, Mars. I mean, it's big oil. They're all over this. And of course, what's going to be limiting in this value chain is new sources of feedstock oil. And that's why it's so attractive to be in camelina today.
So looking out over the next decade, how much SAF do you think that we'll be able to produce on a reliable basis?
So I think, if you look at it globally, obviously a lot. I think what we're sort of looking at is, you can certainly, from us, what we're really looking at over the next 10 years is getting that first, few million acres of camelina production.
Mm-hmm.
And so for us as a small company, getting to 1 million acres of production is obviously massive. I mean, that's probably 500 million in revenue. They're sort of very big numbers. And again, it's all within this sort of domain of that business. So I look at it more from the point of view of how do we go from thousands of acres of camelina to hundreds of thousands of acres and ultimately to millions. And what needs to be happening as we do that to continue to make sure that when we get to 100,000 acres, we can readily get to 1 million.
Do you have that on your calendar, or do you say we think we can get there by 2030, for instance?
I believe we'll be 1 million acres by 2030. That's the goal.
Okay. Now, you've got a lot of exciting information and news coming in the future. How can folks follow along with what you're doing and learn more?
Yeah, I think you just go to our website, yield10bio.com, yield10bio.com, and you should be able to get information. And hopefully we'll continue to talk to folks like yourself and get the news out.
Well, Ollie, thanks very much for spending some time with us today.
You're very welcome. Thank you.
That was Dr. Oliver Peoples, President and CEO of Yield10 Bioscience, a biotechnology company working to engineer camelina to produce the basic ingredients for sustainable airline fuels, bioplastics, animal and fish feed, and nutritional oils, even for humans. You can learn more, as Ollie said, at yield10bio.com. Yield10bio is all one word, no space, no dash, yield10bio.com. I was intrigued by Yield10's goals when we first talked with them a few years ago, and since then, most people are far more aware of the everyday application of genetic engineering. The still controversial but highly effective COVID-19 vaccines are the product of bioengineering, and now we all know that we can make big changes in society using this technology. And that growing familiarity with biotech will make the topic less controversial with each passing year. As Dr. Peoples explained, contemporary genetic engineering uses vastly greater volumes of data to pre-check the impact on a plant, on the environment, and on people of a gene mutation before actually making the mutation a reality. As we collect more data, these processes become less risky. But of course, evolution is always kind of crazy, and we have to be careful. We'll see how demand for camelina-based oils takes off, but it would not be surprising to me, speaking as a frequent visitor to the farmlands of Eastern Washington, where farmers are looking for ways to conserve soil and improve their revenues, to see 1 million acres or even more camelina in production before 2030. Stay tuned for continuing coverage. We'll have Ollie back on in another year or two. I hope you'll take a moment to share this podcast or any of the other 390 interviews that we have produced on sustainability in your ear. Please, if you'd consider writing a review on your favorite podcast platform, it will help your neighbors find us. You folks are the amplifiers that can spread more ideas to create less waste. Please tell your friends, your family, your coworkers that they can find us on Apple Podcasts, Spotify, iHeartRadio, Audible, or any of their preferred purveyors of podcast goodness. Thank you so much for your support. We truly appreciate it. I'm Mitch Ratcliffe. This is Earth911, and we will be back with another innovator interview soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.